The topic for today's discussion is brainstorm solutions, decide on the best solution, implement the solution, monitor and evaluate. Let's take a step by step approach to problem solving strategies in business, specifically focusing on brainstorm solutions, decide on the best solution, implement the solution, monitor and evaluate. We will use an automobile industry example to make it practical and relatable. Scenario is a car manufacturer faces increased customer complaints about delivery delays. Orders are taking 8 to 10 weeks instead of promised 4 weeks. This is affecting customer satisfaction and brand reputation. First is the brainstorm solution. Gather a cross functional team, that is, supply chain, production, sales, and customer service, to generate possible solutions. Increase production capacity, add more shifts, or hire temporary staff. Optimize supply chain, identify and resolve supplies delays or bottleneck. Improve demand forecasting, align production schedules with actual demands. Enhance communication, set realistic delivery expectations with the customers. Implement technology, use automation and AI to speed up production and logistics. Second is the deciding on the best solution. Evaluate each idea based on its feasibility, cost, time, and impact. Solution chosen is optimize supply chain. Why? Because it directly addresses the root cause of the delay without higher cost or long implementation time. And the plan includes identifying delayed suppliers and explore alternative vendors. Introduce real time tracking for parts and materials. Strengthen relationships with key suppliers for priority fulfillment. Third one is the implementation of the solution. Action plan, short term, negotiate with the current suppliers for faster delivery. Secure alternative vendors as backup. Midterm, implement a supply chain management system for real time visibility. Redesign inventory practices to maintain safety stock for critical parts. Timeline includes 6 weeks for initial fixes, 3 months for full implementation. Budget includes $1 lakh for new tech and supplier contracts. Fourth is the monitor and evaluate. Key metrics includes delivery time, that is reduced from 8 to 10 weeks to 4 weeks. Supplier performance, on time delivery rate above 95%. Customer satisfaction, increase post purchase rating by 20%. Evaluation, weekly progress meetings with supply chain and production teams. Monthly review of customer feedback and complaints. Quarterly analysis of the delivery time improvements and cost saving. Results after 3 months were delivery time reduced to 4.5 weeks on average, supplier on time performance reached 97%, customer satisfaction scores increased by 18%. This structured approach shows how systematic problem solving leads to real measurable improvements. Let's apply the problem solving strategy framework to the petroleum industry, where operational efficiency and safety are critical. Scenario is a petroleum refinery is facing frequent equipment breakdowns, leading to production slowdown and increased maintenance cost. This impact delivery, timelines, and profitability. First is the brainstorm solution. A cross department team with engineering, maintenance, procurement, and operations suggest possible solutions. Predictive maintenance. Use IoT sensor and AI to predict equipment failures before they happen. Upgrade equipment. Replace aging machinery with modern, more reliable systems. Enhance staff training. Ensure operators follow best practices to avoid equipment misuse. Streamline spare part inventory. Maintain critical spare parts to minimize downtime. Review maintenance schedules. Adjust maintenance frequency based on equipment performance data. Second is decide on the best solution. Evaluation criteria includes cost, feasibility, implementation, time, and long term impact. Solution chosen is predictive maintenance. Why? Because it minimizes unexpected breakdowns by predicting failures early, reduces maintenance costs by addressing issues before they escalate, improves production uptime, ensuring delivery commitments are met. Third one is the implement the solution. Action plan includes in phase 1 installing the IoT sensors on critical equipments, that is the compressors, turbines and pumps. Phase 2 includes integrate AI driven predictive maintenance software. Phase 3 includes train maintenance staff on interpreting sensor data and taking proactive measures. Timeline includes 6 months for full rollouts. Budget includes 5 lakh dollar for technology and training. Fourth is monitor and evaluate. Key metrics includes equipment downtime by reducing 30% within 6 months. Maintenance cost cut off by 20% through early issue detection. Production efficiency increased throughput by 15%. Delivery performance ensures 98% on time deliveries. Evaluation includes monthly downtime reports and maintenance logs. Quarterly cost analysis to track the savings. Customer feedback survey to delivery the reliability. Results 6 months later were equipment downtime reduced by 35%, maintenance costs lowered by 22%, production efficiency improved by 18%, on time delivery rate reached 98%. This example shows how a data driven proactive approach can solve operational challenges and drive measurable business impact in the petroleum industry. Now, let's apply problem solving strategies to the agricultural industry where efficiency, sustainability, and yield directly impact the profitability and food supply. Scenario is a large agricultural farm notices a 20% drop in crop yield over the past 2 seasons, leading to revenue loss and supplier dissatisfaction. First is to define the problem clearly. By vague problem is crop yield is low. Clear problem is wheat yield has decreased by 20% over the last 2 seasons, reducing revenue by 2 lakh dollar and leading to supply chain disruption. Secondly, gather the data. First is by soil analysis, nutrient level, pH balance, and moisture content. Weather patterns, rainfall, temperature variations, and drought conditions. Pest reports, presence of insect or disease outbreaks. Farming practices, irrigation schedules, pesticide use, and crop rotation history. Third is the root cause analysis, soil degradation, low nitrogen and potassium levels, inconsistent irrigation, overwatering in some areas and underwatering in others, pest infestation, increased presence of wheat aphids, damaging the crops. Fourth is the brainstorm solutions. Soil improvement includes use organic fertilizers and compost to restore the nutrients. Smart irrigation. Install drip irrigation system for water efficiency. Integrated pest management. Introduce natural predators and rotate pesticides. Crop rotation. Alternate wheat with legumes to maintain soil health. Weather monitoring. Use IoT sensors to track soil moisture and weather conditions. Fifth is to decide on the best solutions. Chosen strategy is combine soil improvements, smart irrigation, and pest management. Why? Because it addresses root causes holistically, improves long term sustainability and soil health, enhances efficiency by optimizing water and pest control. Sixth is to implement the solution. Phase 1 includes apply organic fertilizers and compost. Set up drip irrigation system in key areas. Phase 2 includes introducing natural predators like the ladybugs, and use eco friendly pesticides. Install soil and weather sensors for real time monitoring. Timeline includes 9 months for fully implementation. Budget is rupees 1 lakh. Seventh is monitor and evaluate. Key metrics include crop yields, increase wheat production by 15% in the first season, water usage, reduce water consumption by 25%, pest control, lower crop damage by 30%, soil health, improve nutrient level and pH balance within 6 months. And the evaluation includes monthly soil and water reports. Seasonal yield comparison, customer feedback on supply consistency. And the result after 1 year was yield increased by 18%, exceeding the targets. Water usage decreased by 27%, cutting cost. Crop damage reduced by 35%, improving the quality. Soil health restored with balanced nutrients and better moisture retention. This example shows how systematic problem solving in agriculture leads to higher productivity, sustainability, and profitability.